The binomial theorem. The reason why it's called the binomial theorem is because it's made to handle binomials, which this thing right here is a binomial. And so our goal is to expand a plus b to the nth power without having to do a whole crap ton of foiling. So the first thing we have to understand is what a binomial coefficient is. It's basically a coefficient that goes with the binomial expansion. So for n and r in the integers, such that n is greater than or equal to r, which is greater than or equal to 0. So they're both non-negative, and n would be at least as large as r. So that notation, which is n choose r, or NCR for n choose r, is a binomial coefficient. And is defined by n choose r equals n factorial over r factorial times n minus r factorial. Basically, this is another way that you say, you know, if I've got 5 people, how would I pick 3 of them to serve on a committee? I mean, you would choose 3 of them. How many different ways can you do it, noting that the order would not matter? So like if I select person 1, person 2, and person 3, that'd be the same as if I selected person 3, person 2, and person 1. So, for example, if we look at these, I'd have maybe 6 choose 2. That would be 6 factorial over 2 factorial times 6 minus 2 factorial. So this would be 6 times 5 times 4 factorial over 2 times 2 times 1 times 4 factorial. The 4 factorials drop and you get 15. 3 choose 0. 3 factorial over 0 factorial times 3 minus 0 factorial. Whoa, how did that happen? So that's basically 3 factorial over, if you recall, 0 factorial is 1. And this is one of the reasons why we define it that way, is because it makes this math work very nicely. 3 factorial over 3 factorial is 1. Well, I mean, if you think about it, if you've got 3 items, there's only one way to pick 0 of them. You just don't pick any. 9 choose 3. 9 factorial over 3 factorial times 9 minus 3 factorial. This would be 9 times 8 times 7 times 6 factorial over 3 times 2 times 1 times 6 factorial. The 6 factorials cancel. 3 goes into 9 3 times, 2 goes into 8 4 times, 12 times 7 is 84. And of course, if you've got 4 choose 4, that'd be 4 factorial over 4 factorial times 4 minus 4 factorial. That would be 4 factorial over 4 factorial times 0 factorial, which 0 factorial is 1. That makes 1. I mean, if you've got 4 items, there's only one way to pick all 4 of them. You pick all 4 of them. So now let's see the connection. So what I'm going to do is I'm going to use these binomial coefficients to help me with expansion. Well, this one's kind of silly. Basically, it's 1 choose 1 times, or 1 choose 0 times A plus 1 choose 1 times B. A plus B squared is A squared plus 2AB plus B squared. So you've got 2 choose 0 times a squared plus 2 choose 1 a times b plus 2 choose 2 b squared. A plus b cubed, I use all the binomial coefficients with 3 in them. So this is a cubed plus 3a squared b plus 3ab squared plus b cubed. A plus b to the 4th power is a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. And the part you can't see here, and of course this pattern continues, that this coefficient right here is 4 choose 0. This is 4 choose 1. This is 4 choose 2. This is 4 choose 3. And this is 4 choose 4. So note a couple of notes, we have those, and then note that each term, the exponents on a and b add up to 4 or 3 or whatever matches this power here. And not to mention that each time the power on a drops by 1 and the power on b increases by 1. So you start off with a to the 4th and b to the 0, and you end up with b to the 4th and a to the 0. So that leads us to the following. The binomial theorem. For all n in the integers such that n is greater than 0, a plus b quantity to the nth power would be n choose 0 a to the nth plus n choose 1 a to the n minus 1b plus n choose 2 a to the n minus 2b squared plus dot 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 all the way until you get to n choose n of b to the nth power. So basically, concisely written, that would be the sum from r equals 0 to n of n choose r a to the n minus rth b to the rth. So let's see where that takes us. So I'd like to expand x plus 2 to the 4th power. Well, first off, I know that that is equal to 4 choose 0 times x to the 4th plus 4 choose 1 of x cubed times 2 to the 1st plus 4 choose 2 x squared times 2 squared plus 4 choose 3 x times 2 cubed plus 4 choose 4 times 2 to the 4th. Now, if you noticed, I calculated all these on the other screen. 4 choose 0 is 1, so this would be x to the 4th. 4 choose 1, I mean, we could do all those factorials, but I already told you what it is. So that would be 4 times the 2 that's sitting right here. So this 4 times that 2 would make 8. So this would be plus 8x cubed. Then you've got, that's 6, and this is 4, so that would make 24. So we have 24x squared. Now here's the interesting thing. This is always symmetric. Like 4 choose 1 and 4 choose 3 are the same, because if I'm taking 4 objects and I'm choosing one of them, if I have to choose 3, I'm essentially choosing 1 not to choose. So, I mean, it's equivalent. Instead of choosing 1 to take, I'm choosing 1 to leave behind. And you can do that the same number of ways. So anyway, so 4 choose 3 would be 4, times 2 cubed would be 32. So this would be plus 32x. And then 4 choose 4 is 1, 2 to the 4th is 16, so that'd be plus 16. Now let's do one that has a 5th power on it. 2x minus y to the 5th. Well, that would be 5 choose 0 times 2x to the 5th plus 5 choose 1 times 2x to the fourth times negative y plus 5 choose 2 times 2x cubed times negative y squared plus 5 choose 3 2x squared times negative y cubed plus 5 choose 4 of 2x times negative y to the fourth plus 5 choose 5 of negative y to the fifth. Now, if we figure out what each one of these is, first of all, 5 choose 0 and 5 choose 5 are both 1. There's only one way to do that. And then 5 choose 1 and 5 choose 4 is 5. If you figured that out, those always match the number. So then we really only have to figure out 5 choose 2 because 5 choose 2 and 5 choose 3 will be the same. So anyway, 5 choose 2 would be 5 factorial over 2 factorial, and 5 minus 2 would be 3 factorial. So that would be 5 times 4 times 3 factorial over 2 times 1 times 3 factorial. The 3 factorials drop, and you get 10. So that means that 5 choose 2 is 10. So this 2x minus y to the fifth is going to be, first off, 2x to the fifth would be 32x to the fifth times 1 would be 32x to the fifth. Then this guy right here would be 5, and then this guy would be 16x, and then this would be negative y, or I mean 16x to the fourth, and that would make negative y, which would make negative 80 if you crunch all that out. So this would be negative 80x to the fourth. Then, if I come back up here and get my magic pen again, whoops, there we go. So then this guy, this was 10. Oh man, 10. Oh, 10. And then 2 cubed is 8. And then that negative will cancel because it's squared. So 10 times 8 would be positive 80. So this would be plus 80. Oh, I forgot a y in that one. So then this would be x cubed y squared. So I forgot my y to the first power right here. Sorry about that. So then we have to come up with the second to last term, which would be 5 choose 4, which is 5, times 2x times negative y to the fourth. So that would be plus, excuse me. I actually think, nope, I'm in the wrong spot. I got interrupted. What can I say? So anyway, the second to last term, you've got 5 choose 3, which is 10, times 2x quantity squared, which would be 40x squared, times negative y to the third. So this would be minus 40x squared y cubed. Then you've got plus 10x y to the fourth. And then 5 choose 5 times negative y to the fifth would be minus 1 y to the fifth. Now, I think that would be a good stopping point for this particular video.